Good morning, Riga Dev Days. How you all doing? Good so far? Good conference? Quick show of hands, who was in workshops the last couple of days? I know I was. Yes, good morning, welcome. It's really good to see you all here. Thank you for coming. My name is Beattie, and I'm going to be talking to you today about 20 years of continuous improvement, about the journey as a developer from Windows NT4, which is where I sort of first started doing software development, way back sort of 20, 25 years ago, to modern kind of, cross-platform, the state-of-the-art with Microsoft .NET and .NET Core. And the rationale behind this talk, there's a lot of very interesting ideas in software which have kind of, people have started talking about them, they've got some traction, a lot of interest, and then kind of everyone, their focus shifts and they move on to the next thing. And a lot of the time, software moves incredibly quickly. And so what I want to do is kind of go through that journey and pick out some of the things that I think maybe we should go back and we should revisit. Some of the ideas that perhaps we were a little bit too hasty when we dismissed them. So, quick intro, this is me. Twitter is here, website is here, email is here. I've been building websites since 1992. I built my first website literally sort of way back in the earliest days of the World Wide Web. And I've kind of been, hacking around on code and building data-driven applications and things ever since. I'm a Microsoft MVP with the Visual Studio and Developer Tools program. I run the .NET user group in London, so if anyone's ever over in London and you want to come along to a meeting or you have something that you want to talk about, give me a shout. It'd be really cool to have some of you over there and set that up. I've worked on a whole bunch of things, as well as websites. I've worked on, stuff like user experience design, psychology, Conway's law, recruitment, all kinds of things right across the spectrum. And for the last sort of nearly 15 years, I was working with these people. So Spotlight is a company that's based in London, and what Spotlight does is it's a job information service for actors. Kind of like LinkedIn for professional actors, film and television and theater actors. And I joined them in 2003 when I first started working there. My job title was Webmaster. Does anyone remember Webmasters? Had this business card, Webmaster. I thought this was really cool. What it meant is I knew a little bit of HTML and some databases, and we kind of made the rest up as we went along. Working in that one company, I actually left there on Friday. I just finished last week. So it's very unusual in IT to find anyone who's been in the same job for sort of 15 years. But having been through that process from Webmaster, and then there was a team of 2, and then 3, and then 4 developers, and we moved from kind of classic ASP to .NET to .NET Core to AWS. And because having worked with one company, one of the things that I think is really important when you're doing science and experiments and observations is controlling variables. So I'm not necessarily saying what I'm talking about is correct or incorrect, but I've seen all these changes happen within the same organization, within the same culture. And I think that the perspective of, that perspective is interesting. Being able to say, well, we tried changing from this platform to that platform. Same people, same company, same team, same problems, and this is what happened. So the other thing that I'm going to be talking about is the absolutely incredible rate of change that is, we all take for granted in IT now. It's an iPhone generation 1. This thing came out in 2007, so this is 11 years old now. Now, if you get hold of an iPhone 1 today, if you get hold of one of these, pick one up in a store, it doesn't work. It's still, if you can find one where the battery's still good, you can switch it on. But so many of the innovations that made the iPhone amazing just don't work anymore. So it has a Maps application. You can't upgrade this to the latest version of iOS. This is stuck on like the latest one you can get, I think, is iOS 3. The version of Maps on iOS 3 doesn't work anymore because the APIs that drove it are gone. The version of search interfaces and settings and all kinds of applications on this. The phone itself, the piece of equipment is still okay, but that phone was just the kind of tip of an iceberg. It was part of this massive ecosystem, and all of those applications are gone. All the cloud infrastructure and services that made them work. The really ironic thing about it is, what the only thing that the iPhone still does really well is it's still a phone. So all this innovation and these amazing interactive services, if you get one of these now, it will make phone calls and it will send text messages, because those are the only parts of the whole infrastructure that have not changed. So the mobile industry, mobile phones and smartphones, there's such a massive incentive. They have so much money that there is this constant driver. And they've also conditioned people to this idea that you replace your phone every 18 months, So they can turn things over very, very quickly. But large enterprises, we invest in software and then we're sort of stuck with it. We don't have that appetite for, turnover. We don't have people replacing all of their equipment every 18 months. And so there are these massive code bases out there which are still running in production, which are from the same kind of era as this, So in 2007, the state of the art in .NET software development was web forms and data grids. Anyone here worked with data grids? You remember those? On-item data bound and trying to debug everything, and Microsoft pretending that the web was all like basically Visual Basic. And a lot of that code, the systems that we built using that technology, were frightened of it. It's legacy code, it doesn't matter. People don't care that it's been running in production for 10 years. All the bugs have been found, the issues are worked out, we understand how it works. People are frightened of it because they don't understand it. And we've created this horrible kind of vicious circle for ourselves, And one of the things that doesn't help this, I've done lots and lots of, recruitment, interviewing developers. I've had people leave teams that I've been managing and go and chase sort of, they're leaving. I'm like, why are you leaving? They're like, oh, it's nice here, but I really need to go and learn React and Angular now, otherwise my CV is going to get out of date. And, I think that it's a theme I'm going to come back to later. But, if anyone doesn't want to stick around for this history lesson, they're releasing a JavaScript framework every 5 minutes across in the next room there. I think they're on Vue.js 2.6 now. But we're going to go right back to the beginning, the earliest days of the World Wide Web. So like I said at the beginning, I wrote my first web page in 1992. I'm 14 years old. I'm doing work experience in the university in Bristol in the UK. And it was amazing. Until that point, I'd never seen a network in my life. And suddenly, I've got a week in this computing lab, and we've got FTP and CD-ROMs and Gopher and, all these kinds of things. And one afternoon, they've had a meeting, and they got these handwritten notes, and one of the professors says to me, we're going to put this thing on the World Wide Web. And, I sit down, and I learn how to use VI, and I put some angle brackets in, and make a website. And I don't care about it. I don't realize why this thing is important, And when I get back home, I don't have a modem. I don't have any access to the internet. I don't understand why the web is important. And looking back on it, that seems kind of weird now. But the next time I bumped into the web was 4 or 5 years later, by which time we'd invented graphical browsers. We had invented JPEGs. The web was suddenly a lot more exciting. When the web was really just text and you couldn't display images and stuff in line, there was sort of a limit to how interesting it was, particularly when you're a, sort of teenage boy who's into computer games and video games and guitars and stuff. And we used to get magazines which came with CD-ROMs on the cover, and the CD-ROMs had websites on them. And I actually learned to do HTML authoring by getting these CD-ROMs off the cover of a magazine. I didn't have a modem, no internet access, and I'd go through and I'd take apart the code. I'd look at how it worked. I'd open it up in Windows Notepad, and I'd start picking it apart. And, the sense of isolation that you got out of that was really, really interesting as a way of learning stuff. Nowadays, we're all online all the time. Even when you're trying to learn something, you've got a page open here, and you've got Twitter, and you've probably got WhatsApp running on your phone. You have all these distractions. When I first learned HTML, I was literally sat in a room on my own. No network, no smartphone, no Twitter, no interruptions, just sitting there for 3 or 4 hours at a time, just reading other people's code to find out how it worked. And it's still, it's interesting now. I do an awful lot of traveling, and this is a very familiar experience. You'll be on a plane, and it'll be like, right, I got 3 or 4 hours now. I can get some work done. I'll open my laptop, and I'll go in to start working on something, and I'll think, crap, I should have run the NuGet package restore before we took off. Because the code that I'm working on, you can't even compile the solution now without having an internet connection, because you got your code that you built, but then you need all of the modules and the libraries and the dependencies. And of course, you don't have JavaScript or jQuery running locally. You're getting it from a content delivery network. So, I think it's interesting to actually take the time. When I'm on flights now, make sure you run NuGet restore beforehand. You'll go offline for a couple of hours, and you can actually use that time in a way that people really don't anymore to kind of really knuckle down, immerse yourself, and learn something. A couple of years later, I was building a staff database in Microsoft Access 97. And Access 97, it had this feature built into it where you could literally go into it and you could say you could have a report that you'd made by dragging and dropping things onto a canvas. You could go in and you could click a button that would literally go in and say, I want to publish my database as a website, as the publish to web wizard. And one of the options it gave you here was this thing, Dynamic ASP, Microsoft Active Server Pages. And, it really didn't take long. First of all, you just do it and it would export your report. And then I worked out that you could go in and you could use some of this HTML stuff I learned from the magazines to change the colors and put logos on it. And suddenly at that point, I was a database-driven website developer, I went off to university in 1997. I spent the next couple of years building active server pages and making a bit of cash. I did this in the holidays. And for the first couple of years of my career, we were building greenfield systems. That's all we ever did. A company who had probably no IT, no database, no nothing. They would come to us with a problem or an idea, and we would build a system. And some of them are still running. Some of them went out of business pretty quickly. Now, it's actually, to get this screenshot that I wanted to use in this talk, I had to install Windows NT inside a virtual machine running on my MacBook here. Does anyone want to see how long it takes to install Windows NT on a modern virtual machine laptop? So if you ever did this, you remember this used to take like maybe 2 or 3 hours on a good day with sitting and waiting for next? Watch this. This is installing Office 97 on a Windows NT VM. It used to be my job. We would do this all day, every day. It'd take about an hour ago. And we're done. And the funny thing is, when I actually went through and looked into that, there's a bunch of pauses that they put in it deliberately to give you time to read the terms and conditions. So anyway, and yeah, now I have Windows NT4 running inside a VM on this laptop. But active server pages, that was my thing. I knew the active server pages stack inside out, back of my hand. And it was not a complicated stack. There were these 5 objects that you had to learn. There was request, response, session, application, server. And once you'd learned those, and the sort of scripting languages that glued it all together, you literally knew the entire stack. There were no controls. There was no drop-down lists. There was no repeaters. There was no React components or grid views or any of this kind of stuff. We literally built web pages by just going in and gluing strings together. And it was really, really simple, and you spent a lot of time kind of doing string manipulation, but it was actually really liberating because you very quickly reached a point where you were absolutely confident in your ability to go in and work with that platform. So, compare classic ASP, 1 scripting language and 5 objects. Compare that to a, relatively recent version. So this is not even the latest. This is the .NET Framework 3.5. How many people can confidently say, I know .NET? I know the framework. I know the types. I know the languages. I know all the things that all the different compilers can do. I have spent hours and hours and hours when you're writing a piece of code and you need to throw an exception. And you're thinking, there's probably an exception somewhere inside .NET which covers this scenario, but I don't know which one it is. And so you'll start going through documentation. You'll go through MSDN. You'll look through Stack Overflow. You'll be digging around all these different places, trying to find, what's just the right exception or just the right bit of the class library. And even when it's not built in now, we have the NuGet package library. And so you're like, well, maybe somebody else has solved this problem. And so you go and you start Googling, you look around on NuGet, and you'll find 5 different versions of the same package or 5 different solutions, and it's not quite clear how actively developed any of them or whether they sort of, they have a roadmap. And what I find really frustrating about that is that research is not a linear process. And when we were working in classic ASP, you'd be like, all right, I need to build 8 pages, and I know that it's going to take me 2 days to build a page, so there's probably 16 days of work to make this thing happen. Nowadays, you get into work on Monday morning, you're like, I'm going to look for a NuGet package. You spend a whole day doing research. End of the day, maybe you find it at 5 minutes past 9. You're like, brilliant, this is perfect. Maybe 2 or 3 days later, you're like, I don't think there's anything out there, but maybe I'm just not looking hard enough. And that makes it much, much more difficult to just, sort of manage expectations around the kind of work you're doing, even just to yourself. That sense of confidence of sitting down and going, yeah, I got this, I can do this. Now it's like, well, maybe I can do this. Maybe there's a package out there that I can work with. Maybe there isn't. Maybe there's something in the framework that solves it. I don't know. It's just kind of too big to get your head around. And there's a cycle here. It's a thing that I see played out again and again and again. When I was talking about, discovering the World Wide Web when I was 14 years old, and I kind of didn't care. It didn't solve any problems that I really cared about. And when the first object relational mappers started coming out, things like nhibernate and, those kinds of things, the problem they solved was a real problem I had. We were writing lots and lots of stored procedures to do data access code. And so the first ORM comes along, it's like it'll write your database queries for you. And it's absolutely magic. And you look at the way we would invest our time building these early sites. We'd spend a bunch of time writing stored procedures, and we'd spend a whole bunch of time writing cross-browser testing everything in a whole bunch of different browsers. And so you'd end up with a kind of graph of how you spent your time that looked kind of like this. And then ORMs come along, and the ORMs come along, and you're like, all right, well, now that we've got these ORMs, maybe we can... jQuery comes along. And jQuery is like, we're going to give you a level playing field across all these different browsers. And we're like, okay, now we don't have to do cross-browser testing anymore because jQuery abstracts it away from us. And ORMs come along like nhibernate, and we think, brilliant, we don't have to do data access code anymore. Oh yeah, and we also don't need to do stored procedure design. We don't need to do the database design. Oh, and we don't need to do schema design either. So in theory, by using ORMs and jQuery, our development time would be cut down to like 20%, right? Nah. Because do you remember what websites looked like back in 1999? They look like this. This is Amazon.com, And this is the website they actually launched that they used to sell enough books that now they're one of the biggest cloud computing providers in the world. And, they're putting other companies out of business left, right, and center. We don't expect websites to look like this anymore. Now, you probably could, using jQuery and Entity Framework, knock out a website that looked like this in a couple of minutes. But that's not the expectation that clients and customers have. They want something responsive, something that works across mobile, something scalable. And part of the problem that I see there, or one of the frustrations I see there, is now, even if you're just building tiny little reporting tools that you need to throw together, just you want to get some data off something, or you want to share a dashboard with someone else on your team, we still think, oh, well, we need to start by installing Bower, installing Node, and installing Bootstrap, and getting all these things up and running. But actually, a lot of the time, if you can just get something, even something that looks like this, get it on a server, if there's interesting information in it, if there's stuff in there that people are genuinely interested in and they care about, you can spin this stuff up really quickly. Now, I've not written any customer products in classic ASP for a long time, but very occasionally I found myself needing to dig some data out, and I'm on a server which has nothing installed on it. No Visual Studio, no Node.js, no IDEs, not even stuff like Sublime Text. But you can still run all of these, classic ASP languages and stuff. Back in 1997, ASP was this really weird technology, and it took you about 3 hours to get it working. And now it runs out of the box on every single version of Windows. You just go in, you tick this box. It's built in, baked into the operating system. And, the thing that's interesting here, in 2007, ASP was built into Windows. ASP.NET MVC was the weird technology that it took you a couple of hours to install. And, you kind of had to poke around. It took you a little while to get the thing up and running. And nowadays, ASP.NET is built in, and ASP.NET MVC is built in. And yet, still, has anyone tried to get a recent version of, Grunt or Node.js working on a Windows server? You'd think we'd moved past the point where it takes you 3 or 4 hours just to get a runtime working on the machine you're trying to use to do some work. But we're still going round and round in circles. Because nowadays, people don't want this stuff. It's like, well, we need to be able to install and minify and Webpack and TypeScript and transpile all of our JavaScript components as part of the, the development process that we're doing. And so we find ourselves going round and round and round. The weird thing is, a couple of years ago, we Spotlight migrated our entire stack from being on-premise to being on Amazon on AWS. And the oldest code was actually the easiest. All of this really ancient classic ASP code that nobody has touched in years, we just copied the files across and they ran. ASP.NET MVC, that was particularly like version 2 and version 3. That was so difficult to get it up and running on, a modern infrastructure because the libraries and the modules and the downloads, ASP.NET MVC expects that you installed something in your C program files folder that you downloaded from a Microsoft page that doesn't exist anymore. And I just, I thought it was really interesting that when we initially made that move from ASP to MVC, it was like, this is amazing and it's brilliant. And now 10 years later, the oldest stuff was actually the easiest stuff to transplant onto modern cloud hosting systems. Now, there's enormous value, I think, in minimalism. But that value comes at, I think, a massive cost. There's a risk associated with it. When Microsoft first announced .NET Core, .NET Core 1.0, they had this really, really bold vision. They're like, we're going to give you a cross-platform runtime, a compiler and a language and a really stripped-down minimal runtime library. And you're going to be able to take that, and you, the .NET community, the open source ecosystem, you can build all of the other pieces yourself. They're like, we're not going to give you a web client, but we're going to give you a sockets library that you can use to do stuff on port 80, and then you can use that to build your own web client. And the reason they did this, I think, is that it would have made it very, very easy to port the .NET Core, the runtime, the sort of the heart of the language and the platform, onto as many different devices as possible. You could have run it on iOS, Android, Tizen, smartphones, all the different desktop computer formats. And it didn't work. The community looked at it and went, that's exciting, but it doesn't have this NuGet package that I need, so I can't use it. And .NET Core 1.1 was kind of, an iteration on top of the same thing. And then eventually last year, they finally sort of went, all right, we get it. This doesn't matter how powerful .NET Core is. No one is going to come across unless we port every single, almost all of the libraries and the modules and the runtime. And so they did. They created .NET Standard 2. And so .NET Standard 2 is actually, it's a specification. It's not an implementation. It says if you want to run .NET Standard on your platform, you need to provide all of these things. And there's still some interesting quirks in the way that ecosystem works. There's a thing that says you have to support these interfaces, but you're allowed to throw a platform not supported exception. And I just saw at a Microsoft build the other week, they came out with the announcement that even some of the stuff I thought we'd completely got rid of, like ASP.NET Web Forms and WCF, or WPF, they're now going to bring that across so it runs in .NET Core, but it only runs in .NET Core on Windows, because the big enterprises, they want this migration path. And, I think I really admire what they tried to do in terms of they want this really stripped down minimalist library that you can port to different platforms really easily. But in retrospect, it's kind of obvious it wasn't going to work, because why would anybody, invest their own time in reinventing the wheel, reinventing these components to run on this new platform, which doesn't have any users yet? Now, there's one more thing I want to say about the whole sort of classic ASP era. The pages that I exported from Microsoft Access that I showed you a moment ago, they were all written using VBScript. Every book you could find used VBScript. Every online tutorial used VBScript. The whole kind of classic ASP world all ran VBScript. Everybody used them, but you didn't have to. You could actually run the whole thing in JScript. There was a completely ECMAScript compliant, we're talking ES 1.0 or 2.0, but there was this JScript interpreter built into the platform. So 15 years ago, back in 2003, you could be running JavaScript on web servers. And, JScript supported all kinds of cool things that VBScript didn't. You could have regular expression literals. You could have closures. It had prototyped inheritance. There were all of these powerful, powerful capabilities. You could even do stuff. We had an MD5, a signature algorithm that would run in a browser or in the server. And, nowadays people are like, well, big deal. But this is going back 15 years. And all of this, because best practice said use VBScript, and a couple of teams, including mine, were like, why should we use VBScript when there's a perfectly good JavaScript thing built into this? So, particularly when you're first starting to work on a new platform or a new module or a new sort of runtime framework, it can be really, really difficult to understand the boundaries, to actually go in and kind of break the thing down and think, well, these pieces of it make a lot of sense to us. And these pieces, maybe we should find an alternative. Maybe we should patch them or use something different. So, 2002, Microsoft comes out with this, the first version of .NET. You can tell it's the first version. Well, it says version 2002, but at the time it was just .NET. It was Visual Studio .NET and ASP.NET and everything.NET. And, everyone's really, really excited about it. And it ships with 3 languages. It ships with C#, which is kind of, the de facto. Everyone goes, oh, brilliant, C#, it's a new language, looks like Java, this is fantastic. It ships with Visual Basic.NET, which is kind of object-oriented Visual Basic, and was kind of, anyone here a VB.NET developer? Anyone worked with it? It's got a, yeah, I've done a couple of things with it over the years. It's got some interesting quirks. Like you can do things like put literal XML inside the VB.NET stuff now. But it really did, when it first came out, C# kind of looked comfortable and familiar to anyone who'd done C or Java or, any of the brace languages. And VB.NET kind of looked a bit weird if you were used to Visual Basic, and if you were used to anything else, it looked really weird. And there was JScript.NET, which nobody, I think, ever ran ever in the history of the world, ever. And it lives on today. The Expando object that forms the basis of Dynamics and .NET 4 kind of has its roots all the way back in JScript.NET, but no one ever used it. You couldn't find a single example anywhere on the web of someone who actually built applications using JScript.NET. And, by this point, I've been doing classic ASP and JScript for years. I'm working with a team. We know all the HTTP stuff. We know get and put and post and all of the different kind of quirks and semantics of doing stuff cross-browser and getting performance and working with caching and stuff. And along comes ASP.NET Web Forms. And Microsoft, it looks fantastic in demos. They stand up in these demos and they're like, look at this, you have a web page and you can drag a button and then we double click this button and look, there's the code and you write some code in there and the whole thing, is managed seamlessly for you. Now, I started working with web forms and I very, very quickly kind of went back to doing JScript and classic ASP for another couple of years because the programming model that web forms kind of pushed just didn't feel like building websites. It put so many layers of abstraction between you and between the fundamental technology you were working with that something you'd be like, I just need to put a button on it and then render this, and now I have a data table and I want to do it in alternating stripes like white and gray background stripes. And you literally couldn't do it. You'd end up in all this really complicated event-driven code and on-item data bound and, these data grid rendering controls. And the reason why I think web forms was a brilliant solution. I think it was really, really clever, but I don't think it was solving the problem that we think it was trying to solve. A lot of people think web forms was designed to make it easy to build websites and stuff. What I think web forms was actually intended to do was Microsoft can see that the world is changing. The World Wide Web has come along. It's massive. It's taken everything by storm. There are lots and lots of Visual Basic developers out there in the world who have been building business applications that run on Microsoft Windows. And suddenly people are coming along and going, well, we don't need to run it on Windows anymore. We can build an intranet and we can put all this stuff online. And Linux is coming along, and Apache is coming along, and PHP is coming along, and Perl is coming along, and there's this whole ecosystem. And Microsoft are looking at this, and they're thinking, if all these VB developers decide they need to learn PHP in order to build intranet sites, we're basically finished, because we'll lose all our developers, but also the next generation of businesses aren't going to bother buying Windows because they won't have anything that needs to run on it. And so I think web forms was kind of a very conscious effort by Microsoft to go, we want to keep all of the VB developers. We need to give them a migration path from Visual Basic Desktop to the web. And I think they did that really, really well. And I also, it sounds like I'm bad-mouthing Microsoft a little bit here. I think they did that really well, and I think the stuff that they've done subsequently, up to and including .NET Core and open sourcing, I think they're doing a really good job on kind of all that kind of stuff as well. But this is the observation. Now, one of the things, if you ever go digging into the code that makes up an ASP.NET Web Forms page, they were trying to pretend that the web was a stateless. They were trying to pretend it was a Visual Basic form. They're like, we want to put a text box on the page, and when you click a button, it won't get reset. It'll keep the text in it. And they did it using this. This is view state. They basically took every single piece of state. The web is one of the most powerful stateless pieces of software architecture ever created. First thing they do, they come along and they go, we're going to put view state in it. We're going to put all this crazy wall of encrypted text that stores the state of every single button and every single element anywhere on any of these pages. It worked up to a point, but as somebody who had really kind of got their hands dirty with HTTP and HTML, the stuff really wasn't much fun at all. Now, there's another lesson in there, as I just said it. Understand the motivation. When you adopt a new piece of technology or a new software system, try to understand the motivation of the people who created it. What problem were they trying to solve? Because their problem is not necessarily going to be the same as your problem. I've talked to lots of teams who are like, we have performance problems. Stack Overflow had performance problems. Stack Overflow built Redis. Clearly, we need to use Redis. And you sort of want to sit them down and go, look, Stack Overflow has millions and millions of page impressions per day. You have about 10,000 page impressions per day. You probably don't need Redis. Have you checked your database? Do you have indexes? Do you have primary keys? Could you maybe use some caching? Because there is, again, this sort of tendency in software. People want to feel like they're learning from the biggest and the best organizations. And I love the fact that big companies, Google, Stack Overflow, Apple, Amazon, are so transparent with all the innovation and stuff that they're doing. But the number of people who I've seen, they pick up some library and they're like, we're going to move everything to Memcache because that's what this massive kind of, corporate internet company did. And you're like, your problems are not the same as their problems. Just because it's working for them does not mean it is necessarily going to work for you. Now, remember earlier, talking about classic ASP, and everyone ends up using VB script with it because it's what comes out the box. And then ASP.NET comes along, and everyone jumps on it, and they start using ASP.NET, and they start using web forms, and they're using Visual Studio, and they're using data grids, and they're using all this kind of stuff. And for the first couple of years, the whole community kind of fell into three broad camps. There were the people who stuck with the platform. We have this expression, they drank the Kool-Aid. Every single thing they did came from the same vendor. They used all of the official libraries, all the officially supported things. If they read any material at all, it was probably the MSDN magazine, and that's what they learned to do. There was a whole bunch of people who looked at ASP.NET and went, I don't really like this, and they jumped ship. A lot of them went to Ruby on Rails, which was getting traction around that kind of time. There was this wave of people writing these blog posts about, why I'm leaving .NET. But, there was also this minority of developers who took this really long, hard look at what was going on, and we think there's a different way of approaching this. We think the .NET ecosystem, there are a lot of things about it that we like. C# is a very nice language. The Visual Studio is a really nice development environment. ADO.NET is actually a really capable and powerful set of database libraries. We don't like web forms. We don't like the stuff that's difficult. There's no unit testing framework. It turned out that you could actually build really good applications using C# and .NET without having to use web forms and all the other components. And this was the origins of something that we called the alt.NET movement, which had a sort of peak about 10, 12 years ago. And it started out as a bunch of open source projects. NHibernate, NUnit, Castle Windsor, Monorail, and it grew into this movement. And you can still see the legacy of that movement in .NET projects and user groups all over the world. A friend of mine back in the UK, a guy called Mike Hadlow, he started running an alt.NET meetup in 2009, and he's still running it. It still happens every month. It's a bunch of people, they do .NET, they do open source, they get together once a month, and they just, they talk about the kind of stuff that they're doing. And one of the interesting challenges to alt.NET, a lot of people, they looked at it and they went, we're not going to develop open source projects on the .NET platform because Microsoft will come along and kill them. And NHibernate, got this fantastic amount of traction as an object relational mapper. Now, the story that I've heard from several different sources is big corporate clients will go to Microsoft's developer tools division and they'll say, we need NHibernate, but we're not allowed to use it because it's open source. We need something which is supported by the vendor because our lawyers tell us we have to have supported software for it. And so Microsoft go, well, we've got these big customers who want an object relational mapper. Maybe we should build the Microsoft ORM. And so we get Entity Framework. And Entity Framework version 1, wow, it caused some controversy. Because all the people who are working on NHibernate and things like Castle Active Record and all the other open source .NET object relation mappers, there was a big thing called the vote of no confidence. Entire community sort of rallied around Entity Framework and were just like, this is terrible and it makes all these mistakes and it makes all these mistakes. But they stuck with it, and it evolved. And over the course of a couple of versions, it matured. And so now, in a lot of these cases, we have a choice. And I think that choice is really healthy. The alt.NET, the movement doesn't really kind of happen anymore. There are no more altnet unconferences going on. But that ethos of we can use this platform, we don't have to use all of it. We can use open source alternatives. We can keep the pieces we like, the languages, the compilers, the debuggers, And now that you can do stuff like hosting .NET Core and using .NET Core to build serverless functions that run on AWS Lambda and all these other platforms, the ideas and the questions that originally brought that alt.NET community together, they're as relevant today as they ever have been. And it's not just the particular questions that are relevant. One of the most amazing things about software, I said at the beginning with the old iPhone, it moves so incredibly fast. My first PC had a 12 megahertz processor, it looked kind of like this. And nowadays, you can get a Raspberry Pi for, 5, 10 euros? That is literally orders of magnitude faster. We've had this massive paradigm shift. We used to start out single user applications, they run on one person's desk. And you switch the machine off and you've lost all your work, and then you switch it on again, and you remember you saved everything to disk. And this paradigm shift from single user applications to distributed applications, websites that have to cope with hundreds and hundreds of users and everything. And we come to an event like this, and there's people talking about hypermedia, there's people talking about blockchain, there's people talking about federated authentication and OpenID and clusters and NoSQL databases, and all of these absolutely amazing innovations and things. But still, there's not a week that goes by without some massive IT system failure making the headlines. When I first put this talk together, we just had some snow in London. Now, it doesn't snow very often in London. And the first thing that happens when it snows in London is every single person jumps on their phone or goes on their computer and they go to look up the railway timetable to see if the train is still running that they need to get home. And of course, the entire railway information system collapses because it cannot cope with the load. And then this cold weather caused a bunch of pipes to freeze. And, there's water leaking and people have no water in their houses. So everybody jumps onto the London Water Company's website, which immediately falls down, And all of this innovation, we have all these amazing solutions, but still these really important applications don't seem to be able to cope with the load. And I think part of the reason for that is, you're a water company. What you really need is one web page that says, we do water, there's problems with the pipes, we're working on it. What they have is, a login and pay my bill, and it's all responsive and it's optimized and it works on mobile. And the problems that they've kind of invested in, because these rogue cases, things like, cold snaps and freezing and bursting pipes, because they don't happen very often, they don't include them in the testing scenarios. And the focus has kind of shifted away. And this part of me almost wonders, if you got a bunch of people who were still building web pages like it was 1995, and you said to them, we need a website for, the Southern Railway Company, they'd probably come up with something which didn't collapse, because the scope of the problem they're solving would be so restricted by their technology stack, they'd probably end up with something that actually, just kind of scales. Now, one of the other concerns, the people working with object relational mappers, you start introducing layers of abstraction. People who used to write database queries by hand, now you kind of don't worry about it. The ORM kind of does it all for you. And then, like I said a moment ago, we're having performance problems. Maybe we need Redis. And you're like, well, have you actually looked at your underlying database? Do you understand what's going on? Do you know what the status with your index is? And someone says, what's an index? And you're like, I don't think Redis is the problem you're trying to solve here. So, like a lot of developers, I use Git and I use GitHub for revision control. And I didn't always do that. When I first started out, this was my revision control system. I had floppy disks. I got a couple of disks off my dad, and I'd write my name, and I'd write, Dylan's Amazing Game on one of them, and I'd put it in a drawer. And if I made a change to my program, I'd save it as Dylan's Game 2. And the reason I sort of bring this up, I want to talk about this idea of the journeys that we go on as developers. Because we all start out, there's this idea, I think, in our industry now, that we kind of learned all this stuff, and so we shouldn't be talking about it anymore because it's done. No one's going to go along to a conference in 2018 and talk about, using Subversion for revision control because, hey, we've got GitHub now, it works. But me and a lot of other people, we all developers start out as tiny babies who can't even read and write, let alone use distributed revision control systems. And by the time you're sort of 20 years old, we expect junior devs to be able to come into your team and sit down and write code and do revision control and manage databases and, this whole vast spread of skills. And what are the steps that we go through on the way from, you start out, you got to learn to read and write, and then you got to learn to use computer code. Then you got to learn to type. Then you got to learn to use all of these different, paradigms and stuff. And I have a computing science degree from Southampton, and I had a exam in revision control systems. We were taught CVS, concurrent versioning system. But the problem is, we weren't taught to use it to manage programs. Nobody gave us a code base and said, you need to maintain this code base for the next year or 2 years or 3 years. They taught us to use CVS, and the only reason we had to use it is we had to pass an exam in how CVS worked. So we learned just enough of it to be able to write the right answers on the paper, and then everyone just went back to copying folders and saving copies of things. There were no collaborative projects, and I think this was a massive missed opportunity. You get a university, you've got 3 years, and they could have, on day one, said, bang, here is last year's graduating software. You're responsible for maintaining it now. That would have been a completely different way of teaching. And at that point, we'd have been like, we actually have a real problem here. We're not going to get through this course unless we learn how to use revision control systems. And it's a question of how what's the motivation behind you trying to use the tools that you use. So CVS didn't solve any real problems we had. We passed the exam in it. We went back to doing stuff our own way. First couple of years of my career as a web developer, I used to do deployments using file comparison tools, which is brilliant. Everything was interpreted. There was no compiler. There was no runtime. All you need to do was make sure that the ASP or the Perl or the PHP files on the server were the same as the ones on your workstation. So I used this, Beyond Compare, which is an absolutely fantastic side-by-side file comparison tool. And one of the things that you could do when you had interpreted software and you were using file comparison is, and this is going to sound crazy, but you could deploy backwards. You could edit code on production and then deploy it back to your workstation. And occasionally, I'd have a customer on the phone having a problem, and I'd literally be sat there typing away, the phone on me, I'm like, okay, press refresh, press F5. And they'd be like, oh, thank you, it's been fixed. And people would ring with features like, hey, can you add a button to a page that'll do this? And you could implement it. And, there's probably only 6 months. This doesn't work when you have any kind of team. But when you're just the webmaster and you're working on the stuff on your own and you're also doing help desk, the reputation you get for great customer service is fantastic, because people then, they go out for drinks and they're like, oh, I rang Spotlight and they actually changed their website while I was on the phone. It was fantastic. And there's people out there, customers, who actually still remember and they still talk about this stuff. We did occasionally lose a couple of things, because you'd do a file comparison backwards and something would get lost in the wash. But fundamentally, the problem we were solving was keep the users happy and make sure when you deploy the code, you deploy the right bits.
I'm sorry, you have to wrap it up. It's like coming to the end.
Is it? Yes. Okay, I have 8 minutes on the screen here.
Really? Okay. Yeah. Because it's like 5 minutes for questions still. So.
Okay. So, it worked great. We moved on and we started using Subversion for a vision control system. Then we moved from that onto GitHub. And, the question I think is interesting is the journey that me and developers of my generation went. We started off over here with backup disks. And then from backup disks, we went on to using CVS. And then from CVS, we went on to using Beyond Compare. And then, from Beyond Compare, we ended up using Subversion and GitHub. And the question is, if you just do this, if you go straight from here is code to I'm working on GitHub, are there necessary steps? Are there pieces of this journey from here to here to here to here to here which actually teach you useful skills? Or is all this stuff just crap that we don't need to worry about, we don't need to think about ever again? So, wrapping up very, very quickly, one of the interesting things, I've just started working with these people, Skills Matter in London. Decided it was time to move on. We run a whole bunch of sort of big tech conferences, and their tech stack, the stack I'm maintaining now, is written in Ruby on Rails. Ruby on Rails is not a platform I know very well. I feel a bit like this. And, so what I've come to realize, actually, the code, the value in that code is not the Ruby. The value is that in that Ruby code is every decision that they've ever made about how that company operates. All of the decisions, all the processes, all the business changes that have happened over the year. It's got tests. It's a solid code base. And actually reading through it, sure, you learn a lot about Ruby and Rails and how all that kind of stuff works. But you also learn an awful lot about how the business has developed over the years. You learn a lot about where these changes came from and the reasons why they happened. Anyone here, these legacy systems, they solve real problems. They do real stuff. They deliver real things. The classic ASP that's still running at Spotlight, they just used that to cast the new Star Wars movie. They used it to cast Game of Thrones. They used it to cast, Doctor Who and Sherlock. And, anyone watch the last Star Wars movie? I guarantee there's no one there thinking, you know what, this movie would have been way better if they'd used Ruby to find the actors, because it solved the problem, I'm going to skip forward a little bit. Imagine you got on a plane and the pilot said, good morning, this is your captain speaking. There's going to be a slight delay in takeoff this morning. We upgraded React.js last night and it looks like the latest version has a caching problem. So we're just running Webpack again and we should be on the move within half an hour. Would you stay on that plane? Working software is important. Writing software is fun. We love building code. We love writing things. We love, creating new systems and everything. But I'm sure for a lot of people here, if you've got an opportunity, someone says, hey, we got this great job. It's a 25-year-old healthcare system. It's written in C++. Do you want to go and work on it? You'd be like, no, I'm going to go and work here. They're doing React and Angular and all this kind of cool stuff. But these systems aren't going to go away. They're important. They run in production. They're legacy code, but they work and they solve real problems. And there's all this buzz around learning to code and boot camps and teaching people to quickly build websites in React and Angular and Node.js. I think it's brilliant that we are inspiring people to go in and learn and do all these kinds of things. But I also think as an industry, the attitude that we have to legacy code, to historic lessons, to older systems, needs to change a little bit. This stuff is real and it's important. Finally, I just want to wrap up with, I'm going to leave you with some code. We don't read enough code. You can learn a lot from reading code. If you study English literature, they make you read. You read big, big books. You don't just sit and write little poems and then you go out into the world and it's like, hey, you're a writer now. You study by learning to read. So I want to leave you with one piece of code which I think is absolutely beautiful and readable, which is an implementation of FizzBuzz written in F#, which I think is the nicest piece of FizzBuzz implementation I've ever seen, because it looks like this. And on that note, I am done. Are there any questions?
Thank you. We have time for one question.
We have time for one question.
Anyone? No? Okay, great. Then thank you for your time.
Thank you.
We can finish.